All right, picking up at the second here, we're going to keep going in 1, 2. Independent value, dependent value. So the independent value is usually the x. It's always the value that's not by itself in the equation. So like, if I had one that looked like, oh, I don't know, pi r squared, area equals pi r squared. That's a horrible r, so I'm going to rewrite it again. That's better. If I had an equation like this, the input value, the independent value, the x, with quotation marks around it, would be the r. It's the value that's inside the function because I plug something in, it gets me the a. So it's the one that has stuff going on around it. The dependent value, usually the y, is also called the output value because it's outputted out of the equation. The equal sign is what it becomes. It makes it across there. So when they're asking you what is the independent and dependent, independent is the one that can change the dependent. So like if they ask you a question, the amount of humidity in the air depends upon the water that's been rained down, which isn't exactly a good example, but I'm going to use that example anyways. The water depends on the rain, so the rain would be your independent. Your dependent would be the humidity in the air. Okay? Going on, to get away from my bad example. This equation here, I always have to explain this every time, so I'm just going to write this. If you already understand this, you can ignore this part. But f of 0, which is what this is right here, right? Notice that 0 value is in for the x value. So all that means in terms of the equation is everywhere there's an x, in parentheses, we're going to put a 0. Okay, so in this case, I don't know why I changed colors already. 0 squared is 0 times 2 is 0 minus 0 plus 3. That gets me an answer of 3, right? This next one, same thing. So I'm going to plug negative 7 everywhere there's an x. And I do use parentheses because in cases like this, where those become a positive, because subtracting a negative equals positive, 2 times 49 plus 7 plus 3. 2 times 49 is 98, plus 7 plus 3 is 10, so that equals 108. Okay? I'm going to clear this. If you need to pause and go back and look and see what I did again. Once again, I'm just plugging those numbers in where they belong with the equation. Once again, I'm looking at this. It's where the x is. So all I'm going to do is everywhere there's an x, I'm putting 5a in. Something else I've seen happen is technically this is then equal to f of 5a. This is not multiplication going on right here. So this is just a title of the function. It's saying the function, when I put 5a into it, or a better example would be the function, when I put negative 7 into it, equals this number. This is not actually multiplication, so at the end, please do not divide by 5a. I will probably say that again, but I will repeat it now. Do not divide by 5a. Okay? So when squaring something, we know that you have to square every piece. So 5 squared is 25. A times a is a squared. This one, luckily enough, isn't too complicated. It just equals 50a squared minus 5a plus 3. Okay? Once again, I'm going to clear this. Ooh, hopefully I didn't just break it. Once again, we'll point out a minus 4 is in for the x. So all I'm going to do is everywhere there's an x, plug the a minus 4. I know I've said that like 3 times now. And some of you are getting annoyed, but I don't know how many times I've said it in the past, people have forgotten. So if I repeat myself, hopefully one of the times it will catch in your mind. Just think that annoying time he kept saying the same thing. What was he saying over and over again? Remember when you square something, it's the same as multiplying it by itself. So we have to FOIL that. A squared minus 4a, so minus 8a plus 16. And I'm going to distribute that negative. Distribute the 2. Minus a plus 4 plus 3. So I'm going to take a second and shrink all this stuff. Give you a moment to catch up if you're behind. And by behind, I mean you write slower than makes, once again, work at your own pace. Pause, shut me up, whatever you have to do. Don't forget to combine like terms. There's only the 2a squared here. Ooh, that's a horrible squared. I have 2a's making minus 17a. 32 plus 4 plus 3, I believe, comes out to 36 plus 3 is 39. Okay. That's what those mean. Once again, this is technically equal to this. Doesn't mean you do anything else. You are done with this answer. This is your answer. Don't do anything else. Quit. Okay? Perfect. Down. Vertical line test. I've already talked about this, hopefully, or hopefully you remember talking about this at some point in the past. But the vertical line test says if I take a line and draw it up and down on the graph, as long as these lines only hit the graphs once, that is a function. If they hit the line twice, like here, for example, this one is not a function. So yes and no. Okay? Finding domain of functions. So when we ask for the domain of functions, we're talking what are the values for x for which the function is defined. There are only two types of function that's limited. We've already talked about these, but it's either division or square root. So for me, I'm going to write this the easy way. I'm going to show you the hard way also, okay? So for me, all you have to write for division, what's the one number you cannot divide by? 0. So we have to find when does x minus 5 equal 0.
Lights on, doors.
Shush.
When you leave tonight.
Am I the last one here?
No, we got people coming through to look through the building.
Okay. Lights on, you said?
All the lights on, and all the doors unlocked.
Okay. Sorry for that. Hopefully you fast forwarded there. So I get x equals 5. That's what x cannot be, though, because it would make the bottom equal 0. So this is what I expect you to express for an answer. Once again, though, in terms of ranges, you would write it like this. Because you have every negative number between negative infinity and 5, and then every number from 5 to infinity. But you have parentheses there because it does not include those numbers. So once again, every number from negative infinity to 5, that's what this says. And then we put union because we can't be 5, but every number past 5 we can still be. Square roots, which is part of that trick question from your test, if I left the test alone, which I probably will. Square roots cannot square root anything lower than a negative. So you have to make it so it's bigger than 0. So in this case, that means adding 2. So I get x is greater than or equal to 2. So once again, you can express your answer like this for me in terms of actual college algebra. They will expect an answer more like that. You use the bracket. You use the bracket because it's equal to 2. And we use the parenthesis because you can never equal infinity. So this says 2, the number 2 all the way to infinity works in this equation. So sometimes we have more than one thing going on, like this one. So what number can we not divide by? Hopefully you can do this part in your head. What makes the bottom equal 0? Well, x cannot equal 2. But then you also have the square root, right? So we need x to be greater than or equal to 0 because of that. So I'm going to draw the number line so you can kind of get an idea, and I'm out of time. Dismiss. Gosh. So let me finish this one, then we will look at how much we have left. Maybe we'll just deal with examples like it in class. So from 0 on, let's do it with the red line. 0 on is what this one says. And then this one says, but there is a hole at 2. Meaning that everything is shaded except for there at 2 and everything on. So in terms of the answer, it's going to look like this. Bracket, because it includes 0, and then it goes to 2. But it does not include 2 because that would make me 0 on bottom, and then 2 to infinity. So more or less it was the same as this one up here, except for we cut it off because I couldn't be less than 0. Okay? So let's see what I have left here. I think the rest of this we can probably do in class. If you want to challenge yourself, this one shouldn't be too complicated. You can try it, but we will talk about the rest of this in class. Have a good evening, and I will see you soon.